Hello, my name is Jonathan Lewis. I am a senior Earth and Environmental Science major at Susquehanna University, and this is my project, Atmospheric River Case Studies in the U.S. Mid-Atlantic region. I'd like to give a shout out to my research advisor, Dr. Kathy Straub. The goal of this study was to identify the frequency of ARs in the Mid-Atlantic region, and from the frequencies, locate specific case studies that were significant. And then from the 3 case studies that I picked, drawing comparisons and differences through IVT value graphs, East Coast and regional maps of the Mid-Atlantic region, and cross-sectional maps of the Mid-Atlantic region that I picked. So just a little bit of background, summarized from the AMS definition, an atmospheric river, or an AR, is a long and narrow corridor of water vapor. It ends up bringing a ton of moisture to the area being studied or observed. And similar to the definition that just came out a couple years ago, the scale also came out a couple years ago. On the y-axis, we have IVT, or integrated water vapor transport, and this looks at specific humidity and meridional and zonal winds in a column of air. And on the axis of the scale, we have duration in hours. And so we come up with 5 categories. And so for this study, I had to extend the scale out to the right to match some of the ARs that I got from my results. And so I went out past 72 hours and continued in the diagonal formation and color scheme that was created by the original scale. And so the minimum requirements for becoming an AR was 250 IVT, or 24 hours and 24 hours long, or 500 IVT and 0 hours long. 0 hours long is a little deceiving because the calculations for IVT came from the 6-hour Meritu NASA data. And so 0 hours long just represents 1 6-hour period. And so here's a frequency table. And in better form, here is it in a bar chart. As you can see, AR1s and AR2s are most frequent, and that's good. They usually bring a healthy amount of rain to the area. And this table below shows all AR4s and AR5s that occur in the 2010 to 2019 region. And so I picked 3 case studies, which you can see highlighted, the highlighted rows. And I picked these 3 because the top one is the highest IVT value averaged over the Mid-Atlantic region that I'm looking at throughout this 10-year period. The second one is the second shortest long duration AR, but it happens during the colder months, October and November. And the last one is an AR5 because of its almost 10-day duration during the month of July. And so just before I go into specific case study observations, I'd like to explain what is in each of these animations. So this particular animation is of the East Coast. We have IVT contours separated by 250 IVT. Those are the thicker black lines. We have specific humidity shading, and the color scheme here correlates to the color scheme of the AR scale. This isn't to say that an IVT value equals a specific specific humidity value, rather that the two are directly related in the fact that a higher IVT equals a higher specific humidity, and a lower IVT equals a lower specific humidity. And the arrows in this animation and in the Mid-Atlantic radar map show wind vectors. So looking at the highest IVT value AR is this case study. This is a Category 4 AR. It lasted 4.5 days, and the particular dates are September 27th to October 1st, 2010. All the animations, in addition, are between the day before and the day after of the AR event. This just show what was happening before and after, which in most cases is nothing during the colder months, and it gets a little bit muddier during the warmer months. And so here's the Mid-Atlantic region that I was talking about. So all of the IVT values that I get are averaged over this region. And so if you direct your attention to the IVT line chart on the left, we have each averaged frame over the time that it exists. And you can see that an interesting thing happens 3/4 of the way through the life of the AR is the maximum IVT value. And in the animation, you can see that correlation between high IVT and high specific humidity, but again, not direct number or categories correlation. Here you can see the cross section. At the top, you have the specific humidity, and at the bottom, you can see the IVT value according to its longitude. And the goal here is to show that the thickness of specific humidity rises with the IVT value depending on its location. And so the more colors you see, the thicker the moist air is, and the higher the specific humidity is. And so here's our next case study. This shows an AR moving during the late October to early November period. It's a Category 4 AR, and it lasted 1.5 days. But like I said, this happens during the cold months, and you can see that through the low specific humidity as represented by the white after the AR kind of moves through the area. And so unlike the previous one, where the AR draws its source directly from the south relative to the Mid-Atlantic region that I'm looking at, this one draws its source, its warm, moist air, from the southwest region relative to the Mid-Atlantic region. And as the AR moves up the East Coast, you can see these cyclonic winds that move behind the concentrated IVT values and colors. Looking at the regional view, you can see that the IVT and the contours are relative together in their high values and high and orange and red and purple colors. And again, at the line chart, you see that about 3/4 of the way through the life of the AR, the highest IVT value exists, which might be something to look at further as this research continues past this presentation. And then here's the cross section of this short AR. And this shows that specific humidity and IVT are not only shown in the radar view, but in the cross-sectional view. And on my poster, I have still frames that show, IVT and specific humidity correlation as they're best displayed in 3 still frames on my poster. And here's our final AR case study for this presentation. Just looking at the animation, we have the source of this AR coming in directly from the west. So this is a Category 5 AR because of its duration of almost 10 days. Since it's in July, the warm air is already more north than any of the colder season. And this isn't to say that an AR can't draw its source from a southern region, but rather it it's more frequent for a AR to occur from west to east, in this case during the summer months. And moving into the mid-Atlantic region, as this animation plays, you can almost see pulses of ARs coming through, and this could represent maybe multiple ARs, which would be an interesting thing to also observe after this presentation as my research continues. And so looking at the line graph, you have, again, 3/4 of the way through, the maximum IVT point exists. And here's the cross section. So this particular AR doesn't go above 700 IVT, but even here you can see that the connection between IVT and specific humidity and its thickness through the atmosphere is direct. As the IVT increases in its longitude, so does the thickness of specific humidity and the moist air that's moving through. And so just a summary of all the observations that I made throughout my case studies. Looking at the East Coast animations, during the first 2 case studies, the fall events occur ahead of a surface low pressure system, and the warm air comes from relatively the south, whether it be directly south or southwest, and therefore results in a high IVT, and that includes the winds that are included with it. The summer AR event includes possibly multiple pulses, and so that'll be something to observe maybe later in my research. And in addition, after the AR exists, you can see these very high, low-level specific humidity events to kind of contrast the high specific humidity within the AR. In the Mid-Atlantic animation map slides, within the line charts, you can see high IVT amplitudes about 3/4 of the way through of the AR. And then moving on to the vertical cross section, we see these deep tropospheric moisture present in all events, and the contrast in moisture depth between AR and the post-cold front air masses in all the fall events in general exist. And just a general trend that comes from categorizing all the ARs from my 2010 to 2019 study is typically the longer duration ARs occur in the warmer seasons, and the shorter ones happen in the colder seasons. Following this presentation and the conference, my goal is to continue case study analysis and possibly add another variable, integrated water vapor, which is very related to IVT, integrated water vapor transport, mathematically. But it might help with the pulses that you saw and splitting up that AR possibly in the July AR, category 5 AR. And then in addition, my goal is to extend the study out to 40 years from 1980 to 2019. Thank you. If you have any questions, I will be presenting my research, including this poster below, January 10th at the AMS Student Poster Conference. And if you have any questions before or after that point, you can email the email address above. Thank you very much.